Now, case study 4 is St. Jude's Northwest Tower. This is in Fullerton, Southern California, just outside Anaheim, if I'm correct. Now, this is a 220 square foot medical center. It's going to be a brand new facility for St. Jude's, who is a very large healthcare owner in California. And they are working on this tirelessly and are implementing location-based management systems, LBMS, as well as using a CPM schedule purely for contracting. So the LBMS schedule is their operational, and the CPM is to satisfy their contract requirements. So really what we're going to focus on in this case study and kind of bringing this full circle, looking at our initial example of ASAP management and what that is like in a CPM environment versus starting the optimization process in LBMS, then the production control process in LBMS on KPOMC, and then moving now to reporting out of the LBMS data. So the GC on this project was very much able to integrate a data collection process, leveraging daily manpower actuals from their reporting system, using weekly site walks with the GC field team. So what was really good about this was we had their LBMS scheduler come out to KPMC for a week and walk through the process with us, see exactly how we did it so that they could make their process repeatable. And that was a really important step forward for them to understanding, how we did it as much as the pitfalls to be aware of and how we could successfully leverage the process that we defined on the hospital tower that we applied then to the SMOB and use it on Northwest Tower. What our client learned, and this is from the horse's mouth, if you will, but he found that it was a lot easier and a lot faster for him to update and report out in the LBMS schedule comparative to trying to analyze and report out in the CPM schedule doing the same function. Standardizing the daily reports from subcontractors made it easier for them to input resource actuals, so that was a very big lesson learned. But I think that what was more important was understanding that you have to create a plan on the same level of detail as you would plan to control that project. And so what I really mean by that is if you give somebody a complete floor of work, is that really how they're going to complete that floor, dependent on that phase of work that they're doing it in? Are they going to pour one complete slab on one floor if it's over 30 or 40,000 square feet? Probably not. That pour is going to have to be broken up. So we need to control the work on the same level of detail that we are planning it and vice versa. So this is a look at the St. Jude Medical Center Northwest Tower weekly owner's report. And this is the first page that we get. And you can see that they're tracking the superstructure in this weekly report and the tasks that will be included in this weekly report. On this first page, we purposely put what we call a location breakdown structure. So this is very similar to other CPM schedules' work breakdown structure. However, our location breakdown structure uses physical locations of work that we chop and divide up in the 3D model in the Vico office environment. So you can really see what is in sequence 1 versus what is in sequence 3. So you can get that visualization. It's very helpful in showing subcontractors where they might be working or what that desired flow is. So again, now we're looking at the sequence here of the sequence of the installation of the superstructure steel. So sequence 1, sequence 2, 3, 4, 5, 6 around the building in a clockwise fashion. Now, this is the second part of the report, and this is what we call a control chart. This is a fantastic tool for reporting as well as managing, and I like to call this the superintendent's back pocket schedule, and something that we gave out on a daily, if not, sometimes definitely weekly, but definitely daily. Subcontractors got this in the weekly meetings, but this is the control chart, back pocket schedule. So we're looking at the locations of work here. Along the bottom, we have the tasks that exists in those locations. And then each of these boxes refers to a location of work where erect steel will be occurring. And we can see the top numbers here. That's our should start, should finish date, or target start dates, versus these numbers at the bottom, which are our actual dates. You can see this stoplight system, where green indicates that the work is, or that location is 100% complete, it's closed out. Blue is in progress. Red in this instance means that the task has not begun and is running late. So that's where we start to see these notes here, and we have this legend at the bottom as well to give a clearer picture of what are the different stoplight colors mean in relation to this. But what's really great here, and I'll get into these numbers in a moment, but what could be 30 pages of a CPM document, a Gantt chart, is one page. We have so many locations here. 15 locations here. We have, looks like 10 tasks. If we multiply that out, we have over 150 data points here that are visual, that have colors associated to them. It's so easy to pull out an 11 by 17 or an A3 with this information and see this all in front of you. And so when it's reported out, you can see that we've made these observations, or our client made these observations here, that refer back to point number 15 and 16. And again, when we start to look at the flow line forecast, we can see the actuals have been inputted here. We can start to see some of the forecasting behaviors that are being observed for the erection of that steel. Again, hitting on the transparency, the visualization of the flow line view. We can see the direct, this is a screenshot of the completion report. I put it into an Excel format before, but you can take a screenshot directly from the software or use the export to a spreadsheet function that is available to you. And we can start to analyze at a location level what's happening with the erection of steel. What's our target quantity of steel in each versus the target consumption, target production rate. What was the targeting begin time versus the target completion? And of course, we can start to analyze on those locations that are in progress or that are complete what their actual consumption and actual production rate was. So again, this is a snapshot of the control actions log. And we can see the reference numbers of 15 and 16 having been implemented here. So, for example, if we read through this, the start of structural steel is forecasting a late start. The reason was bad weather, inclement weather in the month of April, which impacted the ultimate project. But we're not seeing any impact to the critical path. So no actions required. So again, these are observations that we're making as we're collecting data, as we're analyzing the schedule. We're trying to log this so that there is a historical breadcrumb trail of what has happened, what we were looking at. And we can always go back in Schedule Planner to look at that. And in case study 4, Northwest Tower, we looked at a parallel process. CPM for the schedule, LBMS for the operation. Integrated data collection to streamline the information requirements that are needed to really leverage the LBMS process. Because at the end of the day, garbage in, garbage out. So if you can get everybody involved, not just at a contractual level, but at a convenience level by implementing a spreadsheet in your ERP or your project management tool like Prolog, for example, that you can now collect this data and leverage it into your LBMS environment. Now we're talking business, and we're really getting everybody involved in the process as well. And when subcontractors, when superintendents, foremen, project engineers, project managements are starting to see the benefits of managing production, we're starting to see a very long-range view of relationship building down the line. And certainly one of the real big key learnings was if you're going to create a plan, create that plan on the level of detail in which you plan to control the project. So really understanding how that resource flow, how those sub-trade handoffs are really going to be making a difference to the project.